Hello and welcome back to another video. This is the Programming Duck channel. My name is Spiros, and today we'll be talking about code units at the edges of your application. Alright, so the reason why we're talking about these is because they are a direct application of the fundamental programming principles. Okay, so if you want to write good code and clean code that adheres to those principles, this is probably a topic that you need to know about. Now, specifically, we'll be using edge code units rather than any code unit, just because it's simple to use them to illustrate these concepts. But of course, just like anything, after you learn these concepts, you can apply them to any code unit, and they will also serve as good practice, good training for the programming principles in general. And if you want to fast track this video, it can basically be summarized in the following example. Version 1 of this code is worse than version 2 of this code. And hopefully as we go through this video, I can show you why. Okay, so let's get started. So to start with, edge code units, what are they? So an edge code unit is a fairly small piece of functionality that doesn't have any dependencies, and it does some fairly low-level stuff, and basically it doesn't call any other functions or any other methods to do its thing. And what should those functions or methods, method or function is equivalent here, but I'm going to use the term function for the most part. And what should those functions be like? So they should be small. They should only do one small specific thing. The name should clearly describe what it does so that it's nice and predictable and you understand it. And it should be independent. It should be easy to reuse, easy to change, all the good things that we learn from programming principles. And here are some examples of good edge code units and also some examples of bad edge code units. We'll go through these one by one, right? We'll compare the good version versus the bad version and why the good version is preferable and what problems the bad version has. But for now, just notice that the good versions don't have any conditionals. Okay, there are no if or else statements in there. They do very little. They're all one-line function bodies. They don't read or write anything to their parameters, except for the function appendElementToBody, and that's a JavaScript thing. That's because the document in JavaScript is global. And finally, they don't have any side effects unless the only purpose of the function is to do a side effect. Okay, so before we compare each one individually, here are some general notes. In general, the good versions of the functions, they're very easy to understand. It's very easy to see what they're doing, and you can see that they work predictably without unintended side effects or things like that. They're easy to reuse, easy to change, and easy to test. The bad versions of the code are harder to understand. They may not do what you expect from reading the name, right? They do additional things. They have weird conditions in there and things like that. They're not generally reusable. They are more brittle and more difficult to change, and they are harder to test. Okay, so enough of that. Let's go through the examples one by one. We will start with the humble add function. Okay, so here's the good version, here's the bad version. And now I know what you're thinking. You're thinking, who the heck would ever write an add function anyway? So it's somewhat of a fair point, but let's just say that there are valid reasons to have one. Okay, some of them may be you may need to pass it into a higher order function like map, if you're doing functional programming or something like that, or you may need to use partial application. Okay, so like you have the add function and you do partial application on top of that. Even if you don't do that, this is just to showcase the concepts. The point is that you very well may have functions that are like add. For example, consider that you might have a function named form user greeting, which accepts a username and a user flair, and all it does is adds them together. So it's basically the add function with a different name for the parameters and the function name, but it's exactly the same. So you may very well have functions like these. So now back to the actual add function. Okay, so if we look at the good version of the code first, you can see that it's extremely simple to understand. It does exactly what you expect from the name. It's reusable anytime you ever need it, and it's easy to test. And now the bad version of the code isn't the same as that, unfortunately. For starters, it has a weird function signature that you may not expect, right? It's an add function, but it accepts one argument. And at first glance, that might take you by surprise, which breaks the fundamental principle of KISS, that code should be simple to understand and things like that. And the function would confuse you until you looked at its source code or some documentation or something. But with a good version of the code, you immediately understand it and you can use it easily. Another thing is that this function is just not reusable unless you always want to add the number 5. You can't reuse it with any other numbers. And again, go back to the example of a real function. You may have the function form user greeting. You can't reuse it with any other user flares, right? If the user flare argument is hard-coded at least. Now, that's all well and good, me telling you about this after the fact, but you might be thinking, okay, so how do I make sure I code the good version of these functions in my own code where I don't have someone to tell me, here is good, here is bad. So in general, what you need to do is you need to make sure that your functions don't read anything, they don't access anything outside of their local scope. Okay, so here the good version of the add function only works with the arguments that it's received. It only works with its parameters. But the bad version of the add function accesses something outside of its local scope, right? So for example, value to add, that variable, isn't a parameter of the function. It's outside of its local scope. So when you're defining your functions, as much as possible, make sure that you don't access anything outside of the local scope of the functions. Okay, so the next example is a function named getProperty, and it's basically exactly the same as the add function. So here is the good version of the code, here's the bad version of the code, and they have exactly the same concepts. Okay, so once again, the good version of the code is that it's 100% predictable, easy to understand, easy to reuse, and easy to test. The bad version of the code may not do what you expect straight out of the bat, right? Until you look at the source code. So you may not expect it to have some hard-coded object somewhere and it reads properties out of that. Even the function signature itself may surprise you because you're thinking it accepts a getProperty argument, but where's the object argument, And it's not easy to reuse, right? You can't reuse it with any other object and things like that. So again, what do you do to make sure you've coded the good version rather than the bad version? You make sure that your function doesn't access anything outside of its local scope. Okay, so next, let's look at some functions that may seem more realistic. So the next one we're going to look at is appendElementToDOM. Okay, and here is the good version of the code. Here is the bad version of the code. Now, what's the problem here? So unfortunately, even though it may not seem like it, the bad version of the code can be quite bad because you just don't know what it does unless you look at the source code. There is no other way from the name of the function that you would expect it to have some weird condition where it wouldn't add the element to the body sometimes, right? So that is why that's bad. Now the problem here is that tomorrow you may have a bug in your code base. Pretend that you have some kind of to-do application, and sometimes the to-do, remember this is a bug, this isn't intended, you make a to-do and it's not being added to the DOM. Now the problem is that unless you specifically remember how this function works, right, the function appendElementToBody, which means unless you specifically know where the bug is before you even start, it's going to take you a while to find that bug. And the reason for that is because how you would think of it in your head, right? You have a to-do application. Remember, you think, okay, the user at some point clicks the submit button to create a new to-do. And then a function fires that's been, that's the event listener, right? A function fires. In that function, you would expect the following things to happen. The function checks, first of all, if a to-do like that already exists. Okay, prevent duplicate to-dos. Then, if that test passes, then it creates the to-do object or whatever, and then finally it appends it to the DOM. Okay, like in that order, and that's where you expect the check to be, right? You don't expect it to be down there, you expect it to be in a sensible place up here. So when you're debugging, it's going to take you a while to find it because it should be here. This is the first place you're going to look, and this down here is the last place you're going to look at. So that is why debugging is going to be harder. And now that's one thing. Appending element to body, not business critical. What if you had a condition like this in your database somewhere, in your database code? Then, you're really in trouble because that is a really critical thing. And not just that, like if you have one function like this, where a bug could come up and it takes you a while to find it, you may have functions like these all over your code base. So in general, don't do this, okay? Have the good version instead. Now the point is that your edge code units in particular should be 100% predictable. We spoke about this. It should do one thing, it should be reusable, all of those things, okay? So some ways that you could at least improve this situation, right? Say you need the condition. An improvement to this would be this code right here, okay? So with this code, at least it has a parameter named excluded selectors, right? So if you have a condition, at least it's clear from the function signature of the function, okay? So, if you're using the function for the first time, you understand more about how it works and those kinds of things. So that's one step better. Still not enough, in my personal opinion. I would prefer something like this version. So now we've renamed the function maybe appendElementToBody. And this name makes sense because that's what the function is doing, right? It appends the element to the body sometimes, not all the time, depending on some selectors. So this is much better than the bad version of the code, okay? Even better still, as we've already discussed, is to have the good version of the code and to move the condition to the appropriate place. You wouldn't expect the condition to be in there because, well, if that condition is in there, like the function doesn't do what it says in the name, it is not reusable because you can't just pick it up from your to-do whatever place and use it somewhere else because that other place won't need that weird condition. And it's harder to change because there is more code in there and all those things. So just as an example, here is some example code for what your to-do application could be like. So in this code, as we've already said, we have the function at the top, handle new to-do submit, which is the function that gets called when the user clicks on submit new to-do, okay? And the condition is basically the first thing in there, okay? So we have if does to-do title already exist, right? That's where the check is. That's where it makes sense for the check to be. And then if you look further down towards the bottom of the code, we have the function appendElementToBody, which does what it says on the tin, okay? Yeah, so all that stuff. To summarize, it makes everything easier to work with and makes debugging easier as well. Okay, next, we have the function doubleSpeed. And this follows, again, the same concepts as the appendElementToBody function. And also some of the first examples, because the bad version of the code is reading from, well, outside of the local scope, right? As usual, the good version is one line long, it doesn't have conditionals, it does exactly what it says on the tin, it's reusable, it's easier to change. If there is a bug or whatever, it's easier to change this version. All the good stuff that we want from good code. And the bad version, well, multiple mistakes on this one. So first of all, once again, it has a weird condition that you would not know was there unless you looked at the source code or some documentation, which means it's worse than the function that actually does what it says on the tin, okay? And not only that, but in this case, it reads from outside of its local scope, which is even worse. We already spoke about it with the appendElementToBody function, but yeah, it's harder to understand. It's basically not reusable if you need a different condition elsewhere and all that stuff. So what we should do in this case, just like before, is have the good version of the code, and then the caller of that function can decide whether it needs to call it or not. The condition shouldn't be in, like in the bad version of the code. The condition doesn't belong there, right? You don't call a function named doubleSpeed and it has a condition for whether it should do anything or not. That's just, when would that ever make sense? Like if you think about it from a non-coding point of view, from like a common sense point of view, if you call doubleSpeed, you double the speed. It doesn't have a weird condition where sometimes it does nothing. So the caller checks whether to call that function or not. The condition should be higher up in a more sensible place. Which brings us to the last function in this example. So the good versions are incrementSpeed damaged and incrementSpeed basically normal. And this is game development stuff for the sake of example. Now don't look too much into the hard-coded numbers, the 0.5 and the 1. This is just to showcase an example. In real code, you would probably not have those hard-coded and whatever. Okay, but anyway, this is the good version. The bad version is the worst code we've encountered yet, in my opinion. We'll see why in a second. We have an incrementSpeed function. It works like the first two, but the big problem here is that this function accepts a Boolean as an argument. Okay, the variable isDamaged is a Boolean. The problem is that every time you pass a Boolean to a function, you run the danger of doubling the code paths of that function. So if you look at the good version of the code we had, the functions, they do one thing, one line each, okay? But the bad version of incrementSpeed with a Boolean, it has if-else. If Boolean is true, do this, otherwise do that. Twice the potential code paths of the good versions. This is okay if you have one Boolean, but the problem is how these functions grow, okay? The problem is that if tomorrow you pass in a second Boolean or a third Boolean, now you've got 4 code paths, 8 code paths. And trust me, I've worked in places where it grows more and more and it becomes a monster. But let's start simple. Let's examine a function named sendData. Okay, it accepts 2 Boolean arguments. Okay, so here it is on the screen. Now look at this function. It's already quite complicated. It has a number of code paths and it does a lot of things basically. Let's be honest, it breaks basically all the programming principles, okay? This function is difficult to understand. It's difficult to change because you want to change the code path for formatting the data. You have to read through a lot of code, make sure you only change the correct bit. It's difficult to reuse because if you need a different condition tomorrow, you need to modify this function. You need to add another Boolean. We'll see that in a second. And it's difficult to test because you need a different test, at least one, for every different possible code path. Now in comparison, let's look at the good version of this code. Now at first glance, it may not seem a lot better. Oh, and by the way, please ignore the hard-coded stuff. Again, this is just for the sake of example. But anyway, you have these functions now. SendData, one line, simple, immediately easy to use. You immediately understand what it does. You can reuse it anywhere you want in the code base, and we'll see that in a minute. Easy to test. And it also has the report data error function, which is basically some extracted functionality from the previous example. Well, the bad version, rather. Now, the main function doesn't look too good. And you may argue, in fact, that why is this the better version? All we did is take some of the code from the sendData function and move it into main. And those are the unit functions, the edge code units themselves. Okay, not the main function, but the unit, the edge code units. Super simple to understand and reuse and test. And if you need to extend what the code does, this is the big one. It's much easier to do with this version. Okay, so let's look at how this function grows in the future compared to the bad one. Back to the bad version. Tomorrow we need another condition. So the function grows even more. It now accepts another Boolean argument, needs special formatting, and this is very difficult to understand. It does even more stuff. Everything bad that we had from before is basically worse now. Okay. The main functions themselves, they're not too bad, I guess. But let's compare it to the good version of the code. So here is the good version of the code. So as you can see, the edge code units all remain exactly the same. We don't touch them. There is no chance of breaking them. We don't need to redo the tests. We can reuse them anywhere. And the main functions, they're not too bad. Maybe they're a little bit worse than the other main functions, but they're not too bad. But the edge code units aren't monsters anymore. And trust me, I've worked in places where code like this grows and grows and grows, and it becomes completely non-reusable, because you can't add any more stuff. If some little code in your function needs a sendData function, you can't add its condition. And not only that, it doesn't need the other 10 conditions. Okay, so the good version of this code basically grows better. It grows significantly better. So that was the big problem. But there are some other smaller problems as well. One is that the signature of the bad version of the code for calling sendData just doesn't really make sense. Now, it's true that instead of just calling it with true, false, false, for example, you could have variables for those names, right? So you may have a variable for needs special formatting, and you would call sendData, data, and then your variables like needs special formatting. So it's not too bad to read, but you still need to match the variables to the correct location. You know what I mean? It's not so bad, but it's undeniably a little bit worse to use and call than the simple version of sendData. Not only that, we have the problem we spoke about before. If a programmer imports the sendData function to use it, they expect it to have an argument of a URL and the data. They don't expect whatever the heck the bad version of this code is, because the function is called sendData, right? It's not called sendData if valid, otherwise report error, and also format the data if needed. And by the way, you can also do special formatting. It's you wouldn't expect the function to do what it does. And as a summary, the function sendData, the bad version, basically breaks all of the programming principles, right? It does many things, which breaks the single responsibility principle. It's not simple, which breaks keys. It has many conditions with logic coupled together, which makes it difficult to change, which breaks the motivation behind the programming principles themselves. And it's not reusable if you need different conditions unless you add even more logic. And this breaks the open-closed principle. So what do you do instead? You prefer small unit functions that only do one thing. If you have to pass a Boolean to a function, consider instead splitting it into two functions where each of those functions, does one of the two things you need. The main thing to keep in mind about all this is that everything we've spoken about so far is just an application of good programming principles, right? That includes principles like keys, list astonishment, separation of concerns, or single responsibility principle, principle of least knowledge, and a lot more about handling side effects well. In other words, if you're familiar with those principles, you should be able to write code like what we've spoken about in this video, even without this video to tell you about it. But the reason why this video is here is to give you an example of how to apply these principles. It's to get you thinking in the way that those principles get you to think. Can I understand this code? Is it easy to understand? Is it predictable? Is it easy to change? Easy to test? Easy to reuse? Those kinds of things, right? They're the kind of questions you need to be asking yourself to consider whether or not you've written code that is good and easy to work with, which is directly what those principles are there to help you do. Okay, so by seeing this example, hopefully it helps you become more familiar with those principles and applying them everywhere in your code. Okay, now we also mentioned that we would look at how these concepts relate to other units in your code. Okay, so we examined edge code units. Those are fairly simple. But what about other more central code units? So the majority of the concepts still apply, but not all of them. In particular, two concepts don't apply anymore. And those are the conditionals. Okay, so central code units are more likely to need conditionals. And that's because your code just needs to do different stuff under different circumstances. Unless you have like the most trivial application in the world, that's just how it is, right? Based on whatever it is, form validation, is the input field valid, is it not? Your code needs to do different stuff. So you need the concept of different code paths. So more than likely that means you need conditionals somewhere. Now, as for handling those conditionals, the important thing, as we saw, is to put the logic, the conditions, in the appropriate place, where someone would expect it to be, where it's easy to debug, where it makes sense. And not just that, there are other things you can do as well to make conditionals easier to work with. And one example is polymorphism. So, for example, instead of having a big switch statement, right, where you have an object and you ask, okay, is this object type of circle? Is it type of square? Is it type of rectangle? If so, do a different thing in each case. So instead of doing something like that, you might have an object that must have a particular method, like it must have the method calculate area. And then it doesn't matter if it's of type circle or square or triangle, it always has that method, so you can call it, right? If that makes sense. Yeah. For more details on this, please look at the principle of separation of concerns. We have an example exactly like what I said right there. The point is that you must have conditionals in different code paths. There are different ways to do it. Those are two. Put it in the right place and use polymorphism, for example. The other big difference is that your units can't do just one thing. Okay, so the code units we looked at so far, the edge code units, they do one thing. They literally have one line of code. But other units in your code base can't do that. Because if it has like one line of code, well, first of all, there are no different execution paths, right? And anyway, it's just not possible. So instead, your central code units, they should still be small. The concepts spoken about still apply. But instead of doing one thing, they do 3, maybe 4 things at an appropriate level of abstraction so that we can describe it as doing one thing. So for example, here is some code on the screen. We have a function named handle form submit. Okay. What does it do? Well, we can say it handles the form submission. That's one thing if you think of it at that level of abstraction. But if you look at the code, well, it has 4 lines of code in there. You can say it does 4 things. Now, if you go even deeper, you can say that it does like 1,000 things, right? Because the event object, prevent default, who knows what kind of things that does inside the browser. The get data from form does a lot of things in there. It's not one line of code. It's a couple of lines of code. Send data, sends a network requests and whatnot. It's a lot of things. But if you think about it in the correct level of abstraction, you can say it does one thing overall, and it does like 3 or 4 things in the function. That's how you want those units to be. As for the rest of the concepts spoken about, they all still apply from what I can think of. So for example, you still want your units to only access their local scope, right? To not do a side effect unless they only do a side effect. That's both the principle of separation of concerns and also the command and query separation principle. You still want names that perfectly describe what they do. You want them predictable. You want them easy to reuse, easy to test, easy to change, all of those things. Okay, so the majority of things still apply, but you just need to be a bit more pragmatic with your conditionals and how many things your function does. Okay, the final note, and this is something I say in probably every video or most videos, is to remember to be pragmatic. Now, being pragmatic means to always do what's best for your project. Okay, so basically, all of these concepts and principles are just guidelines to help you write code that is easy for you to work with. That's it. They're not laws. You don't have to follow them, otherwise you're an awful programmer. No, they're just there to help you. So you're the professional. You need to use your judgment. Sometimes it's not appropriate to apply these principles. Now, I showed you some of their benefits, and hopefully you can see why it's good to apply them. But you may come across some situations where it's not good to apply them. And one of them may just be you don't have enough time. Maybe you don't have enough time today to write good code because the feature is absolutely urgent, like seriously urgent. It's not like just your product owner is saying it's urgent. No, it's like this feature must go out today, otherwise the company will get sued for like $3 million. It's, properly, truly urgent. So be pragmatic, don't spend a week more and get sued because you wanted good code. Make the code good enough and ship it. You know what I mean? Like, do what's best for your project. And many times, I hope, what's best for your project will be to follow these principles. But anyway, I'll leave that with you. So that's it. That's the end of the video. I hope the concepts we spoke about are useful. I hope they make sense to you. So yeah, if you like the video, please leave a like. If you want to discuss anything that was in this video, if you disagree with anything, if you just want to leave some feedback or just leave a comment, then please leave a comment below. And if you want to see more videos like this in the future, then please click subscribe. All right, thanks very much and see you next time.